INSEE is a proud member of the Siam City Cement Group Public Limited, a leading cement manufacturer in Southeast Asia. The Siam City Cement Group provides world-class construction materials to a host of countries around the world. This includes Cambodia, Bangladesh, Vietnam, Thailand, Indonesia and Sri Lanka. With a plethora of landmarks and buildings that define the skylines of these countries, the Siam Cement Group pledges to be a role model in corporate governance and sustainable development. INSEE Cement, Sri Lanka's premier cement manufacturer, is the brand behind our country's leading cement products and the driving force behind making Sri Lanka more sustainable. With a reputation built on outstanding performance in the quality of our products, unparalleled customer service, the dedication of our employees, our respect for the communities in which we operate, and our ambition to set the standards for the industry of tomorrow, we have contributed to the growth of Sri Lanka with iconic developments across the island. Just to name a few: the Lotus Tower, Altair Residencies, the Colombo South Harbour, Southern Expressway, Mattala Airport, the Kalladi Bridge, the Kotalavala Defence University, Mahinda Rajapaksha International Cricket Stadium. INSEE has cemented its position as the most preferred local manufacturer of cement in Sri Lanka, with its widespread distribution network comprised of over 7,000 dealers in retail segment located island-wide. Today, we have 2 plants in Puttalam and Galle and 2 terminals in Galle and Colombo. INSEE's Sunstar brand is Sri Lanka's first cement product to be awarded the Green Labelling certification by the Green Building Council and was the first blended cement to launch in Sri Lanka. INSEE has a wide portfolio of cements and services to suit all your construction needs. The most popular among them, INSEE Sunstar, INSEE Mahavali Marine Plus, INSEE Extra for mass pouring concrete, INSEE Rapid Flow Plus, INSEE EcoCycle, INSEE Concrete, Conwood by INSEE, state-of-the-art innovation and development facility. Having been a part of Sri Lanka for almost a decade, we will continue to build on our long heritage of shared loyalty, creating trusting relationships with our business partners, people and community, and delivering our promise of building the nation.
Good evening, ladies and gentlemen. Once Hi, Anna. Once Dr. Abdul Kalam said, knowledge is power. So we are talking today about power. We are talking about political power. We are talking about commercial power. We are talking about technical power. We are talking about power in different contexts. But even though it is from any context, any element, any subject, any topic, knowledge is a key thing when we are talking about gaining power. So knowledge is power. So knowledge sharing session, which INSEE is organized by INSEE collaboration with a proper collaboration with the Institution of Engineers Sri Lanka. We are organizing this for the 20th time. Having a knowledge sharing session for 20 successful times is not an easy task. So today, I think we all can be happy from not only INSEE, not only ISL, especially our participants. I think we can be happy that we have organized this knowledge sharing session for the 20th time. During the COVID first wave, we understood that it is important to challenge the epidemic with effort and energy. So we cannot stop any knowledge sharing sessions. So we understood the digital platform will help us to continue our knowledge sharing sessions. So therefore, we introduced knowledge sharing webinar sessions to challenge this epidemic. So today, which we are organizing, which we are holding, is the 5th knowledge sharing webinar session. So today is the 5th knowledge sharing webinar session, while being the 20th knowledge sharing session organized by INSEE with the collaboration with the Institution of Engineers Sri Lanka, IESL. So we invited today to one of the most reputed, well-known and well-established resource person, to conduct the 20th knowledge sharing session and the 5th knowledge sharing webinar session. It is none other than Professor Ranjith Dissanayake, Senior Professor of Department of Civil Engineering, University of Peradeniya, the Chairman of the Green Building Council of Sri Lanka, and Vice President of the Chamber of Construction Industry, Sri Lanka. So Professor Ranjith Dissanayake and the panel members of the panel discussion, which will be followed by the online lecture, and members from ISL and INSI team, and especially our dear participants. Let me welcome all of you. So in order to further welcome from the ISL side, uh, to do the welcome speech and the introduction, may I invite Engineer Manjula Samarasinghe. Not only that, engineer Manjula Samarasinghe is a very good friend and a collaborative stakeholder among these two entities and different and the fraternity. But also he is a coordinator of public events and presentation, ISL Civil Engineering Sectional Committee. So, Engineer Manjula Samarasinghe, may I invite you to do the welcome and to explain the objectives of this today's session.
Thank you, Dishan. Very good evening, ladies and gentlemen. On behalf of the Civil Engineering Sectional Committee of the Institution of Engineers Sri Lanka, again, you all are welcome to this webinar that will discuss the topic structural health monitoring prevents building failure, and we have panel discussions too out the presentation. So without taking much time, I warmly welcome, especially the main presenter today, Engineer Prof Ranjith Dissanayake, and two panelists, Engineer Mangala Silva and Engineer Dr. Pradeep Laksiri. And warm welcome all the members of the IESL and all the staff members of the INSI, and those the members and those who are joined with those who show the interest to join with this presentation, and members of the Civil Engineering Sectional Committee also. Warmly welcome all of you. Actually, Dishan, this is the 7th presentation I remember for this year. The fifth webinar, jointly done with the INSI, and we as Civil Engineering Sectional Committee always appreciate industry giants like INSI organizing such knowledge sharing sessions to educate our engineers and general public in many areas. We appreciate your monthly presentation on various topics as well. And as I remember last year also, we had about 12 or 13 presentations, all are in person, but I think with this COVID pandemic situation, we had to change it to this online. See, Civil Engineering Section Committee always support organization, companies who support this upliftment of civil engineering industry by having this kind of presentations, webinars. And not only for INSI, we welcome all companies who wish to share knowledge, and Civil Engineering Section Committee always supported all the past several years. If I recall the presentations done in this year itself, we had first manufactured sand as an alternative for river sand, conducted by Dr. Musa. Then we had novel technologies for construction roads, Professor Vasanta Mamperarachi. Then we had modern concrete technology, transforming waste materials by Professor Priyan Mendis. Then we had overview of cement standards for performance-based specialized specifications, Dr. Balwaki. Then we had shear retrofitting of RC structures toward the failure, Dr. Hiran Yapa. Then finally we had structural health monitoring of tall building under wind, Dr. Samit Buddhiga. So we had a good knowledge sharing sessions in this year. So hope this will also be benefit our members and general public. And with this remark, back to the control to Dishan to invite Prof Ranjith Dissanayake. Thank you.
Thank you, Manjula. Thank you very much. And I think you have emphasized some vital words: innovation and collaboration. When we talk about innovation and collaboration, I cannot forget the eye to eye of INSI. INSI eye to eye is INSI innovation to industry. We call it innovation to industry collaboration space. So today, we have understood that there's a very veteran Kumaratunga Munidas, a writer, a well-known poet, once said, "Alut aludya notanana jatiya lo nunagi." The nation without innovation will not succeed, will not grow. So innovation is a key thing, especially when we talk about our fraternity today we are gathered here with. So I think INSEE eye to eye, innovation to industry collaboration space has a key stake in organizing this event. So I think our captain is here, captain of our vessel. So may I invite Mr. Jan Kunik, the Executive Vice President and the Commercial Director, Marketing, Sales and Innovation of INSEE Cement to address the gathering and welcome on behalf of INSEE management. Jan, over to you.
Thank you, Dishan. Can you all hear me?
Yes, we can hear you, Jan.
Yes. Excellent. So very warm welcome and good evening. Thank you, everyone from the construction industry and the engineering fraternity to join today's session. I know it's Boyer Day and we postponed it on a short notice from yesterday to today due to the current circumstances around COVID, but a very, very warm welcome to each and every one of you taking the time to elevate the construction industry and to drive innovation in Sri Lanka. So very warm welcome and thank you, Professor Ranjith Dissanayake to join. Engineer Mangala Silva, thank you very much for joining as well. Engineer Manjula Samarasinghe, thank you for being the co-moderator aside of Dishan. And Engineer Dr. Pradeep, also a very warm welcome for the first time this time. So I think on the one hand side, I would like to talk a little bit about a couple of elements. First, innovation. Second, some macroeconomics and certain COVID developments around the globe. And then a little bit coming down to Sri Lanka. It won't take that much time, but I think very important to understand is why we have started the INSEE knowledge sharing sessions together with IESL. And I really appreciate the collaboration over the last 2.5 years with IESL. In the end, I don't look at it from a head of INSEE Cement, even though INSEE Cement is on my shirt. I came back to Sri Lanka after more or less 8 or 9 years, just being in and out at that time. But coming back and seeing what has changed in the construction industry and what has not changed. And I'm always very much forward-looking, future-looking. While today's performance of a company is important, I always look at sustainability, innovation, what progress has been done. And that's actually why I've taken this knowledge sharing session up together with IESL. That's also why I've invested, and I'm very thankful for our group chairman who've made it possible to have our I2I Center, Innovation to Industry Center, being on the ground today in Peliagoda. In the end, all of us must look forward. And when I came back, I didn't see much progress. And all of us know Sri Lanka is a beautiful country. We must keep it beautiful. The planet is beautiful. We must keep it beautiful. Sustainability, CO2 reduction is getting more and more important. And I'm looking a lot at those aspects as well. And I think it's also our responsibility as a leader in the cement industry locally to drive that. So if I just reflect over the last 12 to 24 months, and it's not just about promoting our products or something like that. We've seen our competitors on the journey with superior blended cements as well. We've now saved, only in the last 24 months, more than 4 million tons of CO2 by having this journey together. We have more durable structures, which is excellent to see. And I really, really liked it. In the end, innovation is the driver of a society as well, and to make it competitive. If you look at China, they have copied 20 years. They've copied 20 years. Today, they are leaders in innovation. It's similar how Japan came up. Japan, they copied for 20 years. And after that, they've been ahead of the innovation curve and started innovating themselves. And the same, I think, we can jointly aspire in Sri Lanka. There's so much excellent knowledge available. And that knowledge, we just must bring it to the ground. And that's also this base of eye to eye, from innovation, from brain towards execution on the ground. So I think over the last 2.5 years, we've made big steps all together. And I also thank all of my industry partners, all of my engineers, my fellow customers, but also my competitors, which are in the end also my dear friends, to join this journey. And all of that would not be possible alone. So all together, we've made great efforts. So big thank you. And I think it's great to say that today, the 20th knowledge sharing session, that we've achieved all of that together. And also in the future, we will continue to drive it together so that Sri Lanka at one point of time is ahead, or at least in line with all the other key markets. That's my aspiration, my vision. And that's why I'm driving certain things, whether it's on the product portfolio development, on the blended cement side, on construction practices, so that we can become more effective, more cost effective. Just the other day, I saw a very good analysis from Central in Colombo, from the Central Quantity Surveyors. And for example, it was always the discussion, is cement the main driver in construction? And actually it showed, no, it's not at all. Our local problem in Sri Lanka is not the cost of cement for a structure. Actually, steel is higher and sand is similarly high. But actually the main driver is the labor. So we must work together on how can we be more effective so that construction costs can come down. How can we be more sustainable so that construction costs come down? So I think over the last 2.5, 3 years, we've done great steps towards that. And there are many more ideas on how we can continue to reduce costs for construction so that everyone can afford a solid house. And over the last 6 weeks, with all precautionary measures, I've been a lot in the market and I've visited many households which were made out of wood to big households. But in the end, it's clear, all of us, we must transform to the solid houses. So a big thanks to everyone, but the journey is not at an end. We still need to continue to progress a lot. We need to continue to innovate a lot. And eye to eye, again, is open for everyone. It's free of charge, and we need to drive it together. No one of us alone can have the brightest vision and can get it to reality alone. Then I think, just coming to the second part, if I look a little bit at the macroeconomics and COVID and what is happening around the world, I have to say thank you to Sri Lanka and the Sri Lankan government on how they are handling COVID. We are talking, or when the crisis started in March, we were discussing, will it be a L-shaped recovery, which means it falls down and it stays very long at a low level? Will it be a U-shaped recovery? So it takes a long time to recover until it comes up, but it will come up. Then we have the classical V-shaped curve discussed on the GDP growth. We'll fall sharp and we'll have a quick hike up again. And today we are talking actually W curves, right? And that's exactly what we can see in or around the world, right? We've had the initial impact. Most of the countries had a lockdown. The share markets went a different way, followed thereafter by the true economy. Let's phrase it this way. And we've had the economies came up. Usually the third quarter of this year in most of the economies around the world was quite good. But most of them also shut down now. I'm sure some of you have seen the news regarding France yesterday. Complete lockdown started from yesterday onwards. Germany is going in a lockdown on Monday onwards. The US will start the lockdown after the presidential election, but only because of the presidential election, they'll keep it up, while 80% of the votes have been posted by post already. So we can see a big change there. And I think Sri Lanka, while all of us face those difficulties, especially the people in the Western province right now, I think it is important, and I think the Sri Lankan government is doing the right thing, stopping certain things earlier on than later. So I think overall, also a big thank you there to the Sri Lankan government, to doing the right things, to keep us all healthy and safety for our families, but not forgetting the economic impact. It comes together, and there's a fine balance between cost for an economy, but also cost for the society in general, and GDP growth. I'm sure if all of us have the right discipline, the right innovation as well, and the right measures, Sri Lanka and all of its inhabitants and population will participate if we follow those rules. So I think good job there from Sri Lanka, and I appreciate that also as a person, but also for my family. So thank you there very much. And I think looking at the macroeconomic developments around the globe, many other countries have significantly worse impacts compared to ours. So also there, I think, because the right measures have been taken, we are not as worse as many others, and actually in certain areas at the forefront. And we can also see that with the exchange rate, which is improving for Sri Lanka, which will have a very positive impact on Sri Lanka. So I think, coming to my third element a little bit, everything what's going down will come up at one point of time. I think actually in many areas we have not come down. If we look at thoughts, if we look at the innovation, we are sitting today at a bank holiday, let's call it this way, and we work together. We think about innovation. We think about structural failures, which have happened, which we want to avoid in Sri Lanka, right? We've had the bridge collapse in Italy. We've had the local collapse in Kandy, one in Colombo. I'm sure we will touch all of these. We can avoid it if we take the right measures from the inception of a project, from the design of a project, from using the right materials, using new materials, innovative materials, and then moving up. And I think together we can make it happen. We can shape the industry together. We can drive innovation. And Sri Lanka has the potential, clearly has the potential to be at the forefront in the next 2, 3, 4 years, if all of us work together. And for that, I'm thanking all of you. I thank you for the trust given also to NC Cement to drive this together with all of you. I also thank the competitors joining those efforts because that's important, but also all the government stakeholders who have joined on this mission. And with that, I'm handing over to Dishan. I wish us all a very good 20th celebrating or jubilee knowledge sharing session and another 20 more, all of us together. Thank you for all the panelists in the past, for all the lecturers in the past, and also I'm welcoming all the lecturers in the future from any field so that we can drive it together. Thank you very much. Over to you, Dishan.
Thank you, Jan. Thank you very much for your kind thoughts, not only for the kind thoughts, but also for the conceptualized thinking and advices, and also for the leadership. Jan is the Executive Vice President and the Commercial Director, Marketing, Sales and Innovation of NC Cement. Before we proceed to the next item, I would like to see how many participants we have at this moment. We have 234 participants. I think it's a record-breaking participation. We are very happy to have you all here. At the same time, now the next, we are going to the presentation. Our next item is the presentation by Dr. Professor Ranjith Dissanayake. I think, sir, today is the 20th knowledge sharing session and also as the 5th knowledge sharing webinar session. We are very happy. I think we are very privileged and we are very happy to have you here for our session. Professor Ranjith Dissanayake is a senior professor of civil engineering, University of Peradeniya, Sri Lanka, and presently secretary to the State Ministry of Rural Roads and Other Infrastructure. He also served as the secretary to the State Ministry of Urban Development. Professor Dissanayake was a Fulbright Scholar in USA, Endeavour Fellow in Australia, and JASO Research Fellow in Japan during 2007 to 2008. He was awarded the Young Scientist Award in 2007 for excellence in scientific research by the NSTC of Sri Lanka. He received the Overseas Prize of the ICE in 2007, UK, and the Australia Alumni Excellence Award in 2012. He has published over 120 journal papers. He has chaired 10 international conferences. He is a fellow of the Institution of Engineers Sri Lanka, ISL. He is the chairman of the Green Building Council of Sri Lanka and Civil Engineering Sectional Committee of Institution of Engineers Sri Lanka. Also, he is a vice president of ISL. In private sector, he is the chairman of LIGO International Private Limited, ICB Private Limited, Lanka AAC Private Limited, and IIPC Private Limited. He is chairing the 11th International Conference of Sustainable Built Environment. He acquired his BSc Engineering degree, bachelor's in University of Peradeniya, Sri Lanka in 1991 and master's in Ehime University, Matsuyama, Japan in 1995. And he has acquired his doctorate from Ehime University, Matsuyama, Japan in 1998. I know, sir, as a fact that you don't like lengthy profile biography readings, but I think it is very vital and important to encourage these youngsters by knowing you and your profile. Sir, over to you to do the presentation. Professor Ranjith Dissanayake.
Thank you. Hope you can hear me, right?
Yes, yes, it is clear and we can see and we can hear.
Okay, thank you. The title that I have been selected today is Structural Health Monitoring Prevents Building Failure. Before starting the topic, I would like to give my thanks to the ISL team for inviting me to do this presentation, and everybody believes that it's a timely important topic as there are several failures in this country. Let me start with this slide. This is a failure in Bangladesh 2013. When you go to the detail of this one, this was a Dhaka government factory which collapsed due to the structural failure. Number of deaths within the building collapse itself, 1,134. Injuries more than 2,500. That is a kind of eye-opener in the world why we have to keen on safety of the building. With that, I start that when you go around the world, you will see there are so many failures upon building, bridges, and so forth. When you especially go to the building collapse in Dhaka, it is due to the overloading because of the booming of the industry, economy. People get more and more orders, so they keep on increasing the number of floors, the number of employees, and so forth. They never think about the safety of the structure. Eventually, building will collapse. And there are other ways of failing the structures. Sometimes you have the lateral push load, as you see there. The whole building will go sometime. This is something happened during the tsunami 2004. Again, sometimes you get due to the shaking. Fortunately, we don't have much shaking in this country, but country like Japan, US, part of the US, due to the earthquake and so forth, we get the shaking and building collapse. Sometimes due to the wind, cyclone, lifting of the structure will take place. So sometimes full structure will take away, sometimes roof will take away. there are situations we have seen. Then again, there will be some sinking that can happen due to the, of course, due to the earthquake or due to the some movement of the water under the foundation. Sometimes we get the discovery, as you see there, the foundation fail. Depend on the how height and the eccentricity and all that, building may fallen down. Sometimes you don't see as you there will be discovering under the foundation until the building collapse. You never see it. So these are the some of the way that building can collapse, starting from the overloading to pushing and scouring and the shaking and lifting and so forth. So let me come to the Sri Lankan context. There are several failures, but these are some of the highlighted failures. Collapse Vallavat building. So there has been investigation and so forth, but I'm not going into the detail. But I would like to just to see what has happened there. Again, anyway, sometimes the situation is a combination of failures. Right? But anyway, at this time, building has been, the increase in this number of floors. That is, there has been the sand with the raining, and of course, overloading can be part of it. But again, scouring has been taken. As you see there, there's a water stream at the end of the building. The combination may work together and anyway, building collapse. It says that the inadequate foundation and lack of adherence to the safety of the building regulation, and it was built laterally on the edge of the channel's bank. So that means the kind of combination may work toward the failure. Then very recent failure in Sri Lanka is the building collapse in Kandy, 2020. So again, all the communities, authorities are looking for the solution, trying to find out the procedures and so forth. But as usual, after a few months' time, as what happened in the Vallavat, my interest might go. That is what happening. Otherwise, if the one failure happened, we should establish all the. But we, being the professional, we should have been discussing this matter, structural health controlling failure, forensic engineering. During last several years, we have been discussing. Let me see how this building came. This is the photograph before failure, and this is what after the failures. Again, that is also we have noticed that this is again in the hilly area. That there is water movement. I believe it also foundation unstable. Maybe discovering has been taken, but nobody can see that, right? So basically, it can be something like this maybe foundation. There can be the water movement under the foundation, and then the strength of the foundation will lose. Then eventually might fail, as you see there. That's what I remember. So this is the results of it. So now we are now concentrated on the failures in Sri Lanka. So when we discuss about these two incidents, I have a very in a way I see these two are kind of natural disaster, of course partly man-made, but we say that the kind of natural disaster we don't know until it failed, because it was for a while until it failed. So that kind of natural disaster, the way it is natured, we don't know, right? So we'll assume it's a natural disaster, right? Anyway, we didn't see that discovering, we didn't see that the various things, and it went down. But when you look at this failure in Shanghai, in China, this is I see like the purely a man-made disaster, right? But the man-made disaster will explain how this two natural disasters happen in Sri Lanka. I mean, the Vallavat one and the Kandy one. So this apartment complex fallen down, as you see there. But here they have constructed maybe similar 13 tower. Then why only one tower came? That's what I said, the man-made disaster. So this is happened this way. This is how they completed the structure. But why it was a man-made one, they wanted to construct the car park once it is completed. Only in front of this apartment complex, not other places. Right? So they cut, as you see there, not only they cut, they have made another common mistake, they have taken the soil and put it on the other side of that. The soil also trying to push the foundation and nearby area. Then in addition to this one, the raining came the same day, the following day. Right? Then this is like what happened either in Vellavatta or the Kandy, that took the period of time to reduce the strength of the foundation. But in case of China, the Shanghai situation, it came next day, like within a few days' time. So that is again, this cut is a man-made cut. Therefore, I believe it's like a man-made disaster. Other one is the both situation. I see that there's a similarities, but that is taken few years of time. It took only the one day because it was accelerated because of the man-made situation. So then building was tilted a little bit. Then the foundation got the pile foundation got the tension because of the instability. Then it came as you see there. This is what happened. So when you go very close by, exactly this is what happened. The photographs are different, but my belief is that both the Vellavatta and Kandy has a little bit a similar situation. But of course, the now increase in number of floors, design failures, and the accumulation of the sand and the rain, overloading that are there. Basically, this has happened. Then I remember there are a few other failures in Kandy itself. There was another failure 10 years before. Right? We have to at least make sure that there will be a similar failure 2030. Right? With 2010, there was a similar failure, and 2020, of course. Right? Now let's see. Let me see the Kandy failure. Right. So this happened differently than what happened in the Vellavatta and Kandy. This there was a retaining wall supporting the the soil. The retaining wall pushes toward the building. Actually, retaining wall is connected to the building itself. Then, due to the forward pressure, building was pushed as there. Then, what happened? There has been a few cracks and all that. Then, eventually, building came down. Right? So you will see the photograph. So even if you have see the photograph before the collapse, you will see that the electrical post has inclined, and you will see some cracks on the pole in front of the building. That is clearly say that the building has been pushed by the retaining wall. How it was pushed, how the load came due to the water pressure came to the building. Anyway, finally, anyway, my topic is this one. Now I was talking about the Bangladesh failure at the beginning and the number of deaths. That was purely due to the overloading. Why it is overloaded? Because of the demand that they get. It's a government factory. They kept up increasing the number of floors and machines and so forth. They were never think about the structural health. And again, we found that some of the recent failures and 2007 failure and Vellavatta failure all has recent failure that was explained in the photograph. My topic is not about the building failures. That is what we see. That is what we experience. That is what we don't want. then we as a professional and engineer, what is the solution that we can give? That is the important part. So that is the part that I'm going to describe. So where I get this topic called structural health monitoring prevents the building failure. So I'm going to tell you that the structural health monitoring prevent the poor, because it is very, very similar to what human beings are doing. So once we born to this world, so we keep on working. When we are young, we run, we climb. Those who like, they drink liquor, and they can do anything and everything. But next day morning, they will be all right. They recover. But once you become older and older, you can't eat, you can't run, you can walk, you can't drink as you did when you are young. Then you have to, at least at that time, you have to think about your health. You have to monitor your health. Of course, I recommend rather than late till until you become older, if you can keep your health monitored throughout your life, that is a good thing. What happened? We build civil engineering structures or engineering structure. We completely forget about it is health. We have been using, we do anything and everything. We increase the load, we sometimes cut, we remove the plastering and come up with the different kind of heavy attachment. We attach the tiles and we do a lot of changes into the structure. We never think about it is health condition. That is the reason. But some of the structures has been designed over. Some of design, there has been the tolerance in the design also keep some tolerance. So though we do some changes within the tolerance limit, so that's why. But when the structure go beyond this tolerance limit, right? So it collapses. Then only we say the building are collapsed. So let me explain few health monitoring of structures, and just to give you the process of implementing damage detection, so that whereby doing the structural health monitoring, we can detect the damage of the structure if there is, right? So structural health monitoring involves engineering investigation. Do the complete investigation of the structure. I'll during the case studies, I have two case studies. I'll try to explain how this engineering investigation is done. What we can provide from the structural health monitoring, we basically say the conditions of the structure. We can say yes or no. If you say yes, that means you don't have to do anything. You can do. You can continue the usage, but even if you want to increase something or change something, if you say yes, of course. Yes. If you say no, then we may have to wait. If you say no, we have to rectify. We have to provide the rectifying method. Further, we have to strengthen the structure. We have to do something for that. We have to increase the foundation. We have to increase the column, straps, and so forth. Oh, otherwise, we have to do the retrofitting. If somebody is asking the tile, we can say that you can't go with the normal tile. You have to go with the lightweight or something like that. Then we can say that control the usage. If it is if somebody say that okay, I have 10 employees, you can say that you don't go about that much. You better change your the way of using the building. Take all the machine to the ground floor and only for the some light office and so forth. Then otherwise you can, if it is a bridge or something, you reduce the speed of the vehicle or the loads and so forth. We can control. Otherwise, you can say, okay, you have to demolish the building and go for the new one if it is your requirement. If you want to have the requirement in the same place, no point of having this one. That cannot, is in a very bad situation. You can't increase the floors or anything like that. You demolish it. That is the last option. But we never want to go the demolition of the structures. We will have some sort of solution. It is the last option is the demolition. Right? So There are another failure, but I'm always interested in the bridges. That is one of my key area where I entered to the field of structural engineering as well as the structural health monitoring also done in this. Actually, when we look at this one, I was involved in the big project in the New York once I was there. So they have been trying to strengthen all the bridges around the Manhattan Island. I know how much effort that they took in order, but still these bridges are having good. We had a very thorough structural health monitoring. So when I know as I know all the detail how the US Columbia University especially attended this structural health program, I can, when I see this failure, what I said that this is not the accident. This is not the act of the God. This is the failure. But I felt as soon as this incident could have prevented. Actually, this bill, the bridge, that was 2018, as I remember, in Italy. My understanding is this bridge could have, failure could have prevented. So that is the how strong the structural health monitoring is, that I can exactly say with the very much confidence this could have prevented. Then when you go to the some other reason to fail, there are human errors, the carelessness of design and so forth, ignorance and greediness. The greediness is a very good example what happened in the uh, mm, Bangladesh. They were so greedy to produce, and this may be the reason. Ignorance and various other things. I'm not going into the detail, but these are some of the reasons. So when structure is failed like this, is only we started what to do. It can be bridge, it can be trust, it can be anything and everything can come down without any type can come down. So then problem is there's a one party who really worried it. They worried why it came down, what happened to the structure, how it came down, and who responsible for this kind of failure. Then there's a person called forensic engineer who come to the scene and analyze it on and say why it came down, what happened this, how it came down, who responsible, whether it's a problem with the architect or the consultant, contractor, the client, or the another party. Sometimes there will be a political reason for failure. That happened. There are some failures happen due to the political instruction. The poor engineer has taken care of that, and the structure has come down. So that may be the reason. So the forensic sphere can give the solution. But what happened? That is too late, right? So the today topic is structural health monitoring can prevent structural failure. So that this is the last option. That will not give you anything. But of course, the person who is really worried, the owner, client, will at least understand why and how it came down. Claiming and getting the money back is not easy task. But what he should have done is gone for the structural health monitoring and rectify. What of that I'm talking about this. Then all the time, client will be happy to see that structure has been working. So this is what we want as engineers. We would like to see that the structures are being monitored to check their health, structure health monitoring, and rectify to the satisfaction of the code or the depend on the usage, whereby the client will be happy, he or she doesn't not have to be worried. So this is the structure very recently collapsed. I really say the ignorance of the structural health monitoring, total set of bridge. This is happened 1994. With central part of the bridge came down, right? This is, I believe, this is also exactly when you go back to the economical booming in Korea. 1994 is the period where suddenly number of vehicle increase in about increase of the load of the vehicle, they are the goods they are carrying, because the business is booming. So that we never think about the structural health monitoring. This has happened. This happened not only Korea, many developed countries during the pace of development. So many structures at the same period, a supermarket also collapsed in Korea. It is overloading because people are getting more goods than they used to buy, so that they need to have big capacity. So what there is, they had a 4-story supermarket, they went up to 5-story, 6-story. Then the one day whole structure collapsed. So that is the situation. So these things can be prevented if they would have gone for the structural development. So now I would like to explain the structural health monitoring using the bridge in a way. Why I told you even before also, I'm more toward the bridge than building. And this is the one of the first work that we did as soon as I finished my PhD under the supervision of Professor Ranjith. So that I would like to explain how we did it very lightly. So structural health monitoring. This is the procedure. Assessment was done, preliminary investigation we planned, and we did the condition survey and material testing and field testing. We did the condition survey in order to do the analysis. We did the material testing in order to get the present strength of the material. So thereby we can go for the proper analysis. Then we go for the field load testing and we validate it. Then once we go for the validated model, the rest will be much easier. So I'll tell you the procedure. This is where you see that the Kalani Railway Bridge, is sometimes people call the Black Bridge. You may see the from the Kalani Railway Bridge. You can see at when you are traveling from Colombo to Kandy, you should be the right side, right? So what we were asked, they want to know that is as I remember, 107 years old when we did the analysis. They merely wanted to see the condition of this particular bridge. So what this was the condition survey. I mean, we basically physically when each and every element of the structure and understand their condition. And even we used the boat service, and we went close to the piers and all that. All the conditions were well recorded. That is very important. Anyway, it took time, but we did it. Then we did the testing of the material. So we brought some, you might see that we are taking out sample, but of course, before taking out the sample, we have to have another sample and we have to find the best location near it. These are very important. But finally, we get the sample and do all the testing. The one is compression, and we have, even we don't know what real material then and there. And we went to the practical load testing and so forth, because now we want to understand, now there is a presently material that is not available anywhere in the world. That is unique for the material that is there, because that has been subject to the wind, heat, raining and everything. We need to know the present situation of the material. And that was done. Then after that, we did a load testing. Load testing is the critical one, because we have to eventually stop the traveling and the movement on the bridge, or maybe, as I remember, from maybe 9 o'clock to tomorrow morning, next day morning, like. Then we had to bring that is the M8 engine, as I remember, is the heaviest engine that we had in the railway. So we brought it, and we changed the speed like the 5, 10, something like that, 20, 30, 40, like increasing and suddenly breaking on the bridge and doing the various things. We measure the strain, displacement, and acceleration and various things within the way, the most important element within the bridge. So these are some of the data that I'm not going to explain. So then this is very important, finite element model, and which is well-dated finite element. One side you see that the analysis data, other side you will see the data that we obtain from the loading. So you will see that these values are getting closer. It's not that easy to get the close. We have to do various things, and this is easy to see that here getting closer, but it's not that easy to get that closer as you see there. But anyway, we have to anyhow manage it, and we have to do the validation so that we now know that there is a model, is a validated model. That means once you have the validated finite element, now you can do the strengthening, you can increase the life and many things that. And this is the validate finite element model for the bridge, so that we can use it. So that is what the big theory part of it. That is why I confidence in when the failure of this Italy bridge happened, I said that this could have prevented. I'm confident that I can say that we would have done it, right? But we mean not myself, but the world has the technology, but they have not implemented it. So finally, we will go into the detail, and these are the theories what we use. Finally, this will important because the structure can collapse due to the fatigue load. The fatigue life of the different members were calculated. Some members used the 20 years and 24. That means we understand the most critical member for the structure is cross girders and stringers. If they enhance their life, we would have spent the life. So that is that sometimes bridge will collapse due to the small element failure. But if you increase the life of the similar that particular member type or member, you can increase the life any longer. That is what we exactly did it. So structure is still using. So that's what we said failure can be prevented. Right. As the beginning, I have been talking much about the building failures, and I think many people who are attending today would like to know about the more like building rather than bridges. So that I would like to come up with the building partly fail building. So this I have been presented to you. Some of you might have seen, but anyway, listen to it. We did a forensic engineering because when we hear that there is a crack, then we went for the structural health model. Finally, we end up with the retrofitting. So this is the building. It is partly by the factory, partly been under the construction. But what I was informed, there are a few cracks. Why don't you come and have a look? So this is the close view of the structure. So I went there. I found that there are a few cracks as you see there. So these are shear and the bending cracks on the major beam. But keep it in mind, this is just for the self pay. The self pay. This is not due to the loading. This is not being used. So we understand that we started the partly retrofitting of the forensic, partly structural health monitoring. And we got the sample where possible and did the concrete testing and various things. But in the meantime, we did the finite analysis, and we realized there are a few reasons, but the main reason and the critical reason is a design failure. Design is not adequate, reinforcement has not been done. The problem is the design failure, right? Then once we informed the designer from India, they said that they want us to do the retrofitting design, strengthening design, how to improve this. We said that, okay, rather than we do it, you do it yourself. We will do the kind of reviewed part. Right. So that they did the design. So you will see that this is the while the strengthening is done, you see the whole structure, you will see that this what you I have marked in the red, it is not there. That means originally they have not thought about the closing, that they have to go for the shear wall there because of the increase in strength. Also, some of the photograph here you will see the steel and fiber reinforcement core was used to strengthening. Why? Because this is addition. These are addition. Why? They don't want to disturb the structure for the operationally. Keeping the operation is good situation, they do the strengthening. This is also not there at the beginning. They added this, the steel and the, you see some of the steel and the fiber added. Now what we are doing is we are doing the structural health monitoring or the forensic engineering. We realize that the structure is not adequately designed, the design failure. So what we are trying to do is improve the weak element of the structure, thereby finally structure can be used. So this is what you see. Now steel. So now structure, as I remember, I think this was done about 7 years, as I remember, 6 years. The structure has been using during last 7-8 years without any trouble. When recently also we went and we recently been about a year before, we went and did another check. Now structure is in good condition. So I'm getting to my conclusion of the study. So let me see the time. Okay. Conclusion of the structure. Any alteration must be reanalyzed. This is to say that if you want to increase the number of floors, if you want to remove the flow and just rendering and go for the tiling, if you want to any alteration, any removal of the wall or addition or anything, that any alteration must be reanalyzed. You have to reanalyze just sometime. We got the call from the owner of the Empire resident, purchased the 2 apartment and he want to make it to a 1 apartment. Well, of course, the possible analysis. So what you have to do is you have to analyze and see whether this alteration is possible or how it is possible. You can't say sometimes impossible. It's engineer. It is possible, but we will say how you can do it rather than say no. So that means that this is another which I always present. That is the problem. Is it is originally timber deck. The political influence is to go for the concrete. The poor engineer gone for the concrete. Of course, the very good vehicle can move fast, no sounds and anything. But once somebody brought the heavy drum truck at the center, it came down. They would have done the same thing, analyzing the structure, understanding the weak element, replacing that one, that means strengthening or the retrofitting, would have done it. But there can be some other bridges structure that has been removed the loading and going for the concrete, it still survive. I mean, that is not possible because there will be always designer do, there is always a possibility for this. But once it is okay, you can't do the second one. Second one will be similar one, right? Then design review. That is exactly happened in the case study that I find in design. If they go for the design review, so they realize that there is a problem in the design that they would have prevented. Therefore, when you do a design, how much you try to find out there is an error, you will never be able to find out that. It's therefore very, very important that third party review is very, very important. Right? Even otherwise, if it is small design, even you can peer review may be accepted. Other one is a maintenance of the structure is very poorly done. Other one is a structural health monitoring. That is a subject what we are talking about. That we should continue. You know, nowadays big structures and big building has been continuously monitored for the health, attaching the acceleration gauges and displacement gauge and so forth, monitor for the structure. What happened mainly is size of the structure coming down. We forget structural health monitoring at the beginning, and we will continue to correct in the structural health monitoring that make the bridge come down. So this failure of the Italy one that I was talking about, especially the maintenance topic here is today the structural health monitoring can prevent the failures. So with that, I will be concluding my presentation so that we have the enough time for the discussion. We have the good two more panelists, Engineer Mangala Silva and Dr. Pradeep here with me today. So I think you might have the different questions. We can have the discussion in Sinhala and the any language. So before, after the presenting, I would like to again thank you for the INSEE and IESL for arranging the timely important presentation. So with that, I would like to move on to the our panel discussion. I think that is the most important thing, whereby the questions that you have been discussed here, and we can discuss. There can be a among the participants, there will be a senior engineers and who know this subject, and if I made a mistake, they can be corrected. I can so if I have the different opinion, we can discuss. So that maybe sometimes the problem that I was just talking about, the high end of structural health monitoring and how the solution is given big structure. So that is the usually academics way of doing things, but sometimes you may have the very simple problem that you have the crack in the wall and that and this. And of course, we are pleased to answer any queries that you have. Over to INSEE team or Mr. Mangala, over to you. This is my presentation. Thank you so much.
Thank you, Professor Dissanayake. Thank you very much for your valuable information. I think we all agree your knowledge, experience, and exposure was properly blended and presented today. Thank you so much for enlightening us and participating and encouraging us on our 20th knowledge sharing session. Now the panel discussions to be held. So for the panel discussion, we have invited another well-known and well-reputed resources in our country, in our fraternity, which is Dr. Pradeep, a very good friend, and Engineer Mangala Silva, again, a very good friend of all of us in the fraternity. So in order to moderate the discussion, I think none other than is appropriate and suitable. May I invite Engineer Manjula Samarasinghe, Coordinator of Public Events and Presentation, ISL Civil Engineering Sectional Committee. Engineer Manjula, over to you to moderate the panel discussion and conduct.
Thank you, Rishan. Warmly welcome all of you again to the panel discussion. I think everyone knows these three panelists today. Engineer Professor Ranjith Dissanayake, Chairman, Civil Engineering Sectional Committee, and Senior Professor of the Civil Engineering Department of Civil Engineering, University of Peradeniya, and Engineer Mangala Silva, Director, SINAGU Consultants Private Limited, and he is the Honorary Secretary to the Council of the Institute of Engineers Sri Lanka and Council Member, Sri Lanka Standard Institution. Then we have Engineer Dr. Pradeep Laksari, Senior Lecturer and Postgraduate Program Coordinator, Department of Civil Engineering, Open University of Sri Lanka. I believe that all have reasonable understanding on what is called structural health monitoring and why important. This has been actually a hot topic over the past period with the failures of some structures, especially in Sri Lanka. Today, our panel discussion focuses on very practical aspects of structural health monitoring. And if you have any questions, please test me or Q&A chat box, and I will try to honor as much as possible appropriately. Having said that, I would like to level my first question to Prof Ranjith Dissanayake, who is our main research person today. So you mentioned many areas which practical experiences on the importance of the structural health monitoring in terms of preventing building failure, mainly on constructed structures. But we know uncertainty is everywhere in an action-centric process. So we need balanced rational design with defined acceptable constraints. Actually, my question is though, how can we apply these techniques for civil structures under construction, and what major areas we have to give our attention? Hope you will brief on these areas. You have many theoretical and practical knowledge, I think.
Yeah, that is of course possible. So how we do this one? Let me explain this. For example, the building I was talking about the partially failed building. Actually, that building, once we undertook the assignment, we said that do not continue the construction until we give the order. I mean, we give the direction. Whatever the direction, we ask them to continue the structure. But during that period, that in the rest of the construction period, we did the structural health monitoring. We attached the gauges and displacement and strain gauges, and we 24 hours basically monitor the how the changes of this is happening. And again, there has been another similar situation. I remember that in Colombo, while constructing the labor building, labor secretariat, there was an old building. The people who lived there, they worried about that can be collapsed due to the construction of the new building. So what we did was we actually again attached the strain gauges and monitored 24 hours. But some situation we understand the frequency and the displacement is too much. We instruct the people who do the piling and slow down the speed and so on, whereby the impact on the building will be less. Likewise, basically the problem that has close by structure or the building itself can be monitored during the but usually what happens is designer also taking care of the responsibility, strength, the stability of the building during the construction. Sometimes there are situations where design has not considered. Sometimes you overloaded the material onto the constructed floor. That has some failures within the construction. Of course, this kind of situation also structural health monitoring can be done. I hope I answered your question. That is possible. That has been done. That can be done. Hope I answered your question, Mangal.
Yeah, thank you, sir. I think many questions we'll receive later with our participants today. I will honor in times come. Then my next questions goes to Engineer Mangala Silva. Engineer Mangala, first of all, I would like to congratulate you for again electing as the honorary secretary to the Council of the Institute of Engineers Sri Lanka.
Thank you, Manjula.
Yeah. Engineer Mangala, we know that any kind of engineering construction has standard practices and industry norms, but we, as discussed, uncertainty is also always there. Everywhere is uncertainty is there. There's a risk factor. My question is, we have seen some buildings collapse, fail during the construction stage too. What do you think about such failures, and what kind of precautionary measures we can take to avoid such situation? It's a kind of broad question, but I think you can have a good answer for that.
Yeah, Manjula, there can be many reasons, but let me tell a few key factors. Actually, when we go see these previous failures in this country, most of the time during the construction, failures can happen due to, I mean, not enough strength of the formwork system. Basically, I hope all the people knows what is formwork. So we saw that most of the time, even our engineers are more concentrating on structural designs, but not much worried about this formwork system. Especially we know when you are pumping the concrete to the formwork, there should be some sort of a strength. Therefore, it is very important to concentrate on formwork system as well, not only the structure. So during the construction, it is a very critical item. I would say there are so many guidelines also available how to design this formwork system. I would say either engineers has to design it, or else they have to go with some thumb rules and some standard guidelines given in the standard books. That is number one. And another reason is actually Prof Ranjith Dissanayake already mentioned. We saw some kind of materials are loading on top floors, especially the sand type things like sand. What will happen during the rainy season? This sand can absorb water and the load might goes up. So definitely it can fail. So that is one thing. This type of scenario we saw in Velavat also. And the next one is unplanned additions. And when I say additions, it can be the additional floors or extensions. Sometimes, most of the time, these people, I mean, for example, if the small house, people initially put foundation for two-story building. After that, they want to convert into a shop or whatever it is. They will simply add few columns and put slabs without telling to the structural engineer. I think it is very important, this type of cases. I mean, before they are going to do any alterations, it's important to do some sort of a structural assessment, and if it is necessary, they have to do the foundation and column strengthening before doing any addition. I think it's very important to mention here this. Most of the time, most of the householders, they are not willing to tell the truth, or they are not willing to express the real idea of the construction. Most of the time, maybe due to there may be so many reasons. One is the council approval. You know, some areas there are some legal restrictions. Sometimes they are in their mind. I mean, they are planning to have 3-story buildings, but they are submitting only 2 stories for the council. Sometimes they are hiding the same fact to the structural engineer as well. So I think we have to avoid this type of situation. So I think most important that clients should tell the truth to the structural engineers, otherwise they are in trouble. So I can say these are the three main areas.
Engineer Mangala, how would you recommend building materials in terms of structural health in today's context? Because the scarcity, prices, that also I think we have to think of.
It's very difficult to give a general answer, Manjula, but I would say first option is you have to consult the competent person, right? Basically, if you are doing whatever the construction, you have to consult your engineer, number one. Or else, if there is no other way, if you are in a hurry or something, I mean, if you are looking for, better to go for the products with SLSI mark, right? So that at least we know there are some sort of a standard. Okay.
Okay, thank you. Then I would like to get the attention of Engineer Dr. Pradeep. I like to draw your attention on especially the theoretical aspects of some scenarios, Dr. Pradeep. My first question is, as per your understanding, why we have to so concerned about structural health monitoring in these days?
Well, thank you, Mr. Manjula and all, and it's great pleasure to be as a panelist here. Actually, the brief introductions to the structural health monitoring is the process of determinations the reliability of the structure. But not only for the buildings, but that goes for any type of the structures such as bridges, dams, towers, etc., which has already been explained by the Professor Ranjith Dissanayake. So important of these structural health monitoring are basically to determine the aging of the structure, any element or part of it reaching the capacity such as thrust, deformations, and or else structural properties such as bending, shear forces, or else the torsions. It can be even the other type of like a twisting, etc. So whatever the structure being designed by the engineers for the predicted lifetime should be closely monitored to ensure the design properties are being adhered to use it. When we take the building for an example, it is very much needed to see the purpose of the building and the considered load are being applied to the buildings within a lifetimes of the building. However, when the buildings are, altered or else uses for the different kind of the client requirement, so it is very much needed to get the engineering judgment first. So the structural health monitoring is a part of it also. And also sometimes the people wanted to enhance the capacity of the structures. For example, they wanted to have another floor, probably. They wanted to have different kind of, initially designs for the offices, but later on they wanted to convert into the different type of use like a restaurant. So at this time, sometimes the clients are directly taking the decisions without getting any advices from the engineer. So beyond that, the structural health monitoring is actually serving for the economy where some of the structures enhancing the lifetimes, especially through the retrofittings or else the FRP, wherever we discussed before. So that kind of things can be easily done. So sometimes substitute any structure as a new structure. Before that, we can do so many steps. Because of these material reuse, the sustainable accept, the construction times, all these are going to be same. So anyhow, structural health point in a simply way. So even if you want to have a, long run vehicle, so you need to have a proper maintenance and the observations in the vehicles too. So the same things it is applied to the building. So if you want to really perform the buildings, what been designed by the engineers at the initial, so you need to make sure that the observations and the structural health monitoring keep carried throughout the lifetime of the building. So that's finally serves to the better performance of the building.
Dr. Lakshmi, most of the time we observe some clients, actually, as Engineer Mangala said, needs to add one or more floors for the after constructing their buildings. Is there any method to do such actions in safe way? Because it is very common in Sri Lankan context that we can see many areas that, as Engineer Mangala said, without the proper approvals, that is done. Is there any safe way? So what would be the procedure?
Exactly. So of course we can do it. Getting the approval is a must because it is a legal requirement of the Sri Lanka. So if you do any alterations or any part of the building, so it has to be going through the local authorities and get it approved. So that is a must. So I think we should emphasize everyone to do this. But in additions to the floors and alterations within the building is possible actually. For example, my experience in one of the hotels which I have designed for a 2-story building, the later on clients want to have another 2 floors. For this, what you need to do basically, we call this a local element capacity design. So we call this a LEC. Especially you have to see whether the capacity of each and every element where it is going to be touching the requirement designs. And also later on, you need to make sure that they reanalyze the buildings with the additional floors, and you have to check whether it is compatible with that. So what we have done is basically the design for the 2-story buildings, and when it is adding another 2 floors, definitely the columns are not going to be safe, and some other elements. So there are ways to do that. And in the retrofittings, FRP, there are so many ways to do right now: jacketing, steel enhancing. In the engineering professions, we do have some alternative solutions to enhance the client's requirement. But today the problem is sometimes client do what he feel. And initially he plans a lot for a building, and when he's going to add in some things, so he take a quick decision on site. So that ultimately govern to the biggest loss in his property. Probably it will be ended up with the fatal damage. So but not only that. So if For example, fortunately, Sri Lanka, we don't have earthquake. But when you add in the flows or do the alternation, so you have to simulate the structure and see whether how the global structural behavior. So how against the wind, how against the earthquake. I remember when I was in, Italy. So one of the hospital that has been adding some, the building. So the process for the not actually it takes a long process because all of us engineers know the load combination. Sometimes it get when you add in the flows. Sometimes even the critical load combinations might be previously been. Later on, it could be the earthquake. So these kind of understandings to be there. So proper engineering judgments to be taken prior to get any alterations or adding any flows to the building. So simply, even if you consult with the engineer, so that probably the people will think that it might be cost, but engineers will save a lot of money and also the lot of lives if you do any alteration and if you do the good consultations with the engineers.
Manjula, let me add little to the what he was mentioned. But
Yes,
sometimes there are situations where the structure is designed for the post story. But when you go to the another story, actually he was talking about jacketing and everything. Simply you would have gone for the lightweight material. Sometimes there is a once you go to the lightweight itself, the keeping the load coming to the foundation is same. We would have done it. That's all.
Okay, so, some people say that their houses observed some settlements after construction of adjacent building. These are practical questions actually. Can this happen, Dr. Laxari?
Actually, I think if you are a design engineer within the Colombo city, I think everyone is facing this problem. So when you add the buildings on the planet, so it stress the soil. So I think settlement is a key element that has to bear it up. So we know that actually that has to be the part of the geotechnical engineering, but let me give the brief introductions. So we have do the primary settlements and the secondary settlements. When we talk about the consolidations process of the foundation load transfer, but this is not much, related to the file foundation. We are basically socketing to the rock, but when the pile is, driven, so because of this vibration, there can be some issues or some kind of cracks and the settlements. But when you do especially design the raft foundation or the isolated foundation, so this settlement, especially to be analyzed and see. What we do is usually, so we see the soil investigation report and we do the designs and we don't observe and the monitor it. But we need to make sure that the adjacent building, because minimum land plots within the urban areas is now become a 6 perch. So you don't have any, rooms to keep the either side spaces rather than the rear side. So then it is going to the blind wall. Then definitely the other house also sharing part of other lands also sharing the part of the stresses that we are transmissions to the foundation. So in this case, the settlements is the one which is we allowable and we calculate what is the allowable settlements within the building. So, but however, we need to make sure that these elastic or the plastic settlements in the foundations to be within the, allowable limit. Most of the cases, what will happen is in a cities like Colombo, some of the area where the groundwater table is much higher. So at that times, when we even though we do monitoring and everything, the foundation settlements might be go. So in the next house, probably ended up with the sand boiling or probably some cracks or some deformation settlements within the building. In these cases, we need to play the win-win role. Wherever the high-rise building goes up, sometimes the masonry structure, which has been done 100 years back, may not be able to bear it up. So that is the truth that everyone should be understand. But engineer has a, responsibility to make sure that the adjacent building should be kept safe and always monitored throughout the process. So I believe the settlements definitely take a place in any type of structure because of the stresses which is transferred to the soil. But however, the design engineer has capability to do the manage the settlements within the allowable limits. Angela?
Manjula? Hello?
Looks Manjula got disconnected. Professor Dissanayake, until Manjula get connected, shall we answer a few questions in this Q&A session?
Yeah, that is possible. Actually, there was one questions which say that whether are we doing the forensic engineering for the failure of Kandy building? Yes, we are doing. There are few lecturers of the Department of Civil Engineering is currently taking care of that forensic engineering. There's another question. They're asking why I was taking the building bridges as the case studies. I think even my presentation, I told you that I started this forensic engineering through the bridges that may make me more comfortable than building. That naturally comes. Another question is, I have a question for you. When you are providing the additional steel members under the concrete structure provide additional strength, what is the design method that you use? Is there a specific calculation method you have? Right. Now this is what we do. Basically, when we understand, we need to increase the loading of the building. When we understand the capacity of the slabs, columns, and beams is not enough to carry, so we do basically jacketing. Of course, jacketing can be done. Say, assume that if it is a concrete column, you can jacket concrete or steel. But some situation, we go to the concrete, but that will increase the size of the member. Therefore, if it is like hidden places, of course you can, because sometimes we may have to do the strengthening in the lobby. Then the client may not like to see that the structure in the lobby, the column get bigger than it was before. Then at that time we prefer to go for the steel. That is the kind of selection. So sometimes we go with the fiber reinforced polymer. That may not increase the dimension, almost the increase of the dimension is zero. But the problem is then we have to compare the cost. So like that, this aesthetic and the cost are the main criteria why we select the method, right? So nowadays the fiber reinforced polymer is getting cheaper and cheaper, but earlier it was a little bit expensive. Is Manjula back?
Yeah, so there was a small technical failure.
Okay, you can carry on.
Power failure. Okay. Back to the question. I received some question in Sinhala also. Is it okay? I think directing questions in Sinhala for the three panelists.
Totally okay.
Okay, right. එකම සමහර ගොඩනැගිලි අසර ජල මාර්ග වීම හේතුවෙන් ගොඩනැගිලි කඩාවැටීමට ඇති බවට ගොඩක් වෙලාවට අපිට මැසිරි එනවා. ඒ කියන්නේ ඒ වගේ සිදුවීම් වෙන්න පුළුවන්ද නැත්නම් ඒක කොහොමද මේ ජල මාර්ග තුල බිල්ඩින් කඩාවැටීමට ඇති ඒකට සම්භාවිතාව හෝ ඒ සම්බන්ධයෙන් ඉංජිනේර මංගල මම හිතන්නේ
මංජුල මාව ඇහෙනවද?
Yes.
මම හිතන්නේ සිංහල භාෂාවෙන් මහපින්ද මම ඒක උත්තරයක් දෙන්නම්. සිංහලෙන් ගොඩක් වෙලාවට අපි දකිනවා මේක අපිට සමහර කේසස් මේ ළඟදී සිදුවෙච්ච දේවලුත් තියෙනවා. අපිට ඒවා ස්පෙસિෆිකලි කියන එක හොඳ නැති නිසා අපි කියන්නේ. නමුත් අපි දකිනවා ගොඩක් වෙලාවට තමන්ගේ ඉඩම හරහා තියෙන ස්වභාවික ජල මාර්ග වගේ දේවල් අවසරයකින් තොරව ගොඩක් වෙලාවට ක්ලයන්ට්ස්ලා මේ වහලා දානවා. අතර මේක සම්පූර්ණ නීති විරෝධී වැඩක්. පළවෙනි එකක් කියනවා එහෙම කරන්න එපා කියලා. නමුත් විශේෂ අවසරයක් ඇතුව හෝ එහෙම කරනවා නම් ඒ පිළිබඳව විශේෂ අවධානය යොමු කරලා ඒ පිළිබඳව විශේෂඥ උපදෙස් ගන්න කියලා ඉල්ලනවා. මොකුත් හින්දා නෙමෙයි අපි දැකලා තියෙනවා ගොඩක් වෙලාවට එහෙම අපි ගොඩක් දෙනෙක් ඔය ක්ලයන්ට්ස්ලා මේක අත්නෝමතික ලෙස වහලා දැම්මට වහලා දාලා ඒව උඩ හදනවා. හැබැයි ඇත්තම කතාව ඒ වෝටර් ෆ්ලෝ එක ෆවුන්ඩේෂන් එකේ යටින් ආයමත් ඇති වෙනවා කාලෙකදී. ඒගොල්ලෝ කරන ඒ වහන විදිහ හරි නැති හින්දා. එතකොට වෙන්නේ ඇත්තටම ෆවුන්ඩේෂන් එකේ යට තියෙන සොයිල් ටික ඉරෝඩ් වෙනවා. එතකොට ඒක විශේෂයෙන් ප්‍රශ්නයක් තියෙනවා. ඒ වගේම තව අපි ගොඩක් වෙලාවට දකිනවා මේ ගොඩක් අපිට මේ කම්ප්ලේන් එන දෙයක් තමයි මේ ගෙවල් වල මේ සමහර වෙලාවට ක්‍රැක්ස් ඇති වෙනවා කියලා ස්ට්‍රක්චර්ස් බහලා තියෙන වෙලාවල් තියෙනවා. අපි ගියාම ගොඩක් වෙලාවට අපි දකිනවා මේ ගොඩක් වෙලාවට මේ වගේ ක්‍රැක්ස් ඇති වෙන්නේ මේ ගෙවල් වල පිටිපස්සේ කියන්නේ කිචන් ඒරියා කුස්සිය පැත්තට වෙන්නේ. ඒකට ප්‍රධානම හේතුවක් තමයි මේ ගේ හොඳට හදලා ඉන්ටර්නල් ඩ්‍රේන් නෙට්වර්ක් එක මේක හරියට කරන්නේ. එතකොට ගොඩක් වෙලාවට වෙන්නේ මේ ෆවුන්ඩේෂන් වොෂ් අවුට් වෙනවා. එතකොට ඒකත් අපි මේක ප්‍රධාන දෙයක්. ඇත්තටම ෆවුන්ඩේෂන් දැම්මට ඒ ෆවුන්ඩේෂන් සේදී යාම වළක්වන එක ගැන ඉතාමත්ම කාරුණිකව හිතන්න වෙනවා. ඒත් එක්කම අපි තව විශේෂ දෙයක් මේ I think the Manjula raised the question about closing down of water paths, but we have seen the other side as well. Especially sometimes people are willing to construct their houses near water path. Sometimes they initially maintain a gap, just say about 10-meter gap between water path and the building. After some time, these people, those who are in the land reclamation or whatever the authorities, they are increasing the width of the water path. Then the gap between the water path and the building was reduced, right? So then there will be a serious issue. ඇත්තටම මේ වගේ ප්‍රශ්නයක් වැල්ලවත්තේ තිබුණ එක කාලෙක මම හිතන්නේ මේක ගැන විශේෂයෙන් අවධානය යොමු කරන්න වෙනවා. I think this should be the people, those who are residing near this water paths, they have to be really vigilant about the width of the water path and whatever the development to be carried out from the authorities on this water path. මම හිතන්නේ මංජුල
ડોક્ટર ප්‍රදීප අපි සමහරවිට දකිනවා මේ විශාල ගොඩනැගිලි වල බේස්මන්ට් එක පහත මාලේ ඉදිකිරීම නිසා මේ ළඟ තියෙන නිවාස වලට යම් බලපෑම් වෙනවා කියලා. ඒ වගේ නිතර අසන්න ලැබෙනවා මේ ඉන්ඩස්ට්‍රි එකේ ඉන්නකොට. මේකේ මේ පිළිපස්ස තියෙන මේ ඉංජිනේරුමය සම්බන්ධය පොඩ්ඩක් පැහැදිලි කරොත් ડોක්ටර් ප්‍රදීප.
මංජුල දැන් ගොඩාක් වෙලාවට ඉදිකිරීමක් කරනකොට භූමියේ තියෙන ඉඩකඩ ඒ කියන්නේ භූමියේ තියෙන වටිනාකම අනුව බොහොමයක් අය කැමති ඉහළටත් පහළටත් යන්න. එතකොට මේ භූගත අපි කියන භූගත මාලයන් කියලා බේස්මන්ට්. එතකොට ඒ වගේම දැන් බොහෝ විට අර්බනයිස් ඒරියා එක නාගරික ප්‍රදේශවල ප්‍රචලිතයි. ප්‍රශ්නය තියෙන්නේ ඇත්තටම අපි මේ සඳහා දෙන අවධානය කියන්නේ ටෙන්ෂන් එක මොකක්ද කියන එක. මේ දවස්වලත් මම විශේෂයෙන්ම ප්‍රශ්නයක් කියන්නේ ගැටලුවක් ඇති වෙච්ච තැනකට මැදිහත් වෙලා ඉන්නවා. ඩිසයින් එකේ ප්‍රශ්නකුත් නැහැ. ඒ කියන්නේ අපි ගොඩනැගිල්ලක් විදියට ගත්තම ඩිසයින් එකේ ප්‍රශ්නයක් නැහැ. ගොඩාක් වෙලාවට ස්ට්‍රක්චරල් ඉංජිනේර් කාවට යනවා ක්ලයන්ට්. ගිහිල්ලා ඩිසයින් බිල්ඩ් අපේ ගොඩනැගිල්ලේ ඒ අවශ්‍ය ව්‍යුහමය ඩිසයින් එක කරගෙන එනවා. නමුත් මේ බේස්මන්ට් එකක් කරද්දී එතන වෙනමම කතාවක් තියෙනවා. මොකද මේ සඳහා අපි ෂෝරින් ඩිසයින් එකක් කරන්න ඕන විශේෂයෙන්ම. එතකොට ෂෝරින් ඩිසයින් එක විතරක්ම නෙමෙයි ඊට අමතරව අපේ ග්‍රවුන්ඩ් වෝටර් ටේබල් එක ඒ කියන්නේ අපේ වතුර තියෙන මට්ටම ජලයේ තියෙන මට්ටම භූගත පිහිටීමේදී බලලා ඒකට අනුව අපි කියනවා ඩීවෝටරින් වෙල් ඩිසයින් කරනවා කියලා. අපි මම හිතන්නේ ඉංජිනේරු විද්‍යාව අපි ඉගෙන ගන්නකොට විශ්වවිද්‍යාලයේ තුර අපි මේක ඉගෙන ගන්න. ඉතින් මේක අර ව්‍යුහ ඩ්‍රොවිංග්ස් කරනවා වගේ මේකට අදාළ ඩිසයින් එක කරනවා වගේම අවධානයක් දිය යුතු දෙයක්. ඉතින් ඔබතුමා කියන එක හරිය. ඒක හරියටම ඩිසයින් කරේ නැත්නම් සමහර වෙලාවට අපිට සීකන් ෆයිල්ස් හරි මොනවා හරි කරලා ඒ මට්ටමින් කරන්න ඕන ෂෝරින් එකක් අපි මොනවා හරි ටිම්බර් හරි ස්ටීල් හරි යූස් කරලා කරොත් අනිවාර්යයෙන්ම එන අපි කියනවා ලැටරල් නැත්නම් අපිට එන ඒ ලෝඩ්ස් එහෙම ගන්න බැරි නම් ඒ එලිමන්ට්ස් වලට අනිවාර්යයෙන්ම මූවමන්ට් එකක් එනවා ඒ ළඟ තියෙන. ඉතින් මේව විශේෂයෙන්ම දැන් මේ වැල්ලවත්ත වගේ ප්‍රදේශවල මොකද අපි දන්නවා ඒ තියෙනවා විශේෂ වැලි ස්තරයක්. එතකොට වෙන්නේ මොකද ඒ කියන්නේ කොහෙෂන් ලෙස් ගතිය අඩු හින්දා එතකොට ඒක ගන්න පුළුවන් මේ load එක අඩු වෙනවා. එතකොට ඒකින්ද විශේෂයෙන්ම මේ ඉදිරියේදී උනත් දැන් අපි සමහර ලාවට මේකට ජියෝටෙක්නිකල් ඉංජිනේර කෙනෙක් සම්බන්ධ කර ගැනීම අත්‍යවශ්‍යයි. මොකද බියෝ ඉංජිනේරුවෙක් වගේම මේ සඳහා විශේෂ අවධානයක් යොමු කරලා මේ සැලසුම කරගත යුතුයි. මටම මේ පසුගිය වසර තුර විශේෂයෙන්ම තෙමහල් නිවසක කියන්නේ අපි කියන ඕවර්ටර්නින් කියලා. ඒ කියන්නේ සෙටල්මන්ට් එකනේ බිල්ඩින් එක ඇලවීමක් තියෙනවා. එතකොට දැන් මේක විශේෂයෙන්ම අවධානය යොමු කළ යුතු කරුණක් සහ ඉදිරියේදී අනිවාර්යයෙන්ම කොළඹ ප්‍රදේශය තුළ කරන ඉදිකිරීම ඒ කියන්නේ නාගරික ප්‍රදේශවල මේ ප්‍රශ්න බොහෝ විට එනවා. මොකද දැනට ඉදි කරලා තියෙන සමහරලාට ගොඩනැගිලි අතර දෙපැත්තේ තියෙන්න පුළුවන් බෑලන්ස්. හැබැයි දැන් ඒවා ෆිල් වීගෙන යන කාලේ එතකොට එන්නේ දැන්. එතකොට ඒ වෙලාවේ බේස්මන්ට් එකක් කරනකොට අපි අර උදාහරණයකට අනිත් ඉඩමේ තියෙන බිල්ඩින් එක ෆයිල් ඩිසයින් එකක් නෙමෙයි නා රාෆ්ට් හරි software කියන්නේ isolated foundation එකක් නම් ඒ ස්ට්‍රෙස් එකට අනුව බලලා මේක කරන්න ඕනේ. එතකොට ඇත්තටම මේක කවුරු හරි ඉංජිනේර කෙනෙක් මේක හිතනවා නම් ඒ බිල්ඩින් එකේ ඩිසයින් එක විතරක් බලලා කරන්න පුළුවන් කියලා ඒක කරන්න බෑ. ඒ සඳහා ඔබට අර ඊළඟ දෙපැත්ත තියෙන බිල්ඩින්ස් වල ඒ සරවුන්ඩින් ඒරියාස් වල නේචර් එක අඳුරගෙන මේක කරන්න ඕනේ. ඉතින් මේ ප්‍රශ්නය විශේෂයෙන්ම ගොඩාක් වෙලාවට ලීගල් ඉෂුව එකක් ක්‍රියේට් කරන ප්‍රශ්නයක්. අපි දන්නවා කලම්බෝ මේ සමහර ප්‍රොජෙක්ට්ස් නැවතිලා තියෙනවා මේ වගේ ප්‍රශ්න හින්දා. ඉතින් නිසි අධ්‍යයනයකින් යුතුව මේ කරොත් කිසිම ප්‍රශ්න නැතුව කරන්න පුළුවන්. මේ සඳහා විශේෂ අවධානයක් දිය යුතු කියන එක මම තරයේම විශ්වාස කරනවා. මොකද එකක් ඒ ප්‍රොපර්ටියට අදාළව සිදුවන හානිය මෙන්ම ඒ කියන්නේ මේ අපි අපේ ක්ලයන්ට්ස් උනත් සමහරලාට නීති ඉදිරියේ අසරණ වෙන්න පුළුවන්. ඒකින්ද මේ සඳහා විශේෂ අවධානයක් යොමු කළ යුතුයි කියලා මම තරයේ විශ්වාස කරනවා.
ඒ වගේම ඩොක්ටර් දැන් අපේ බිල්ඩින් එක ආසන්නයේ තියෙන බිල්ඩින් එක කඩා ඉවත් කිරීම නිසා යම් ආකාරයක බලපෑමක් ඇති වෙන්න පුළුවන් අපේ නිවසක හෝ අපේ බිල්ඩින් එකට. මේ සම්බන්ධයෙන් තියෙන ඉංජිනේරු පසුබිම විග්‍රහ කරොත්.
අතන මංජුල දියුණු රටවල් වල ගත්තොත් අපි බිල්ඩින් එකක් ඩිසයින් කරනවා වගේම බිල්ඩින් එක කඩා ඉවත් කරන්න ඩිසයින් එකක් කරන්න ඕනේ. අපි කියනවා බිල්ඩින් එක ඉදි කරනකොට කන්ස්ට්‍රක්ෂන් ස්ටේජ් ඩිසයින් කියලා එකක් කරනවා. ඒ කියන්නේ තට්ටුවෙන් තට්ටු අපි බිල්ඩින් එකක් ඉදි කරනකොට බිල්ඩින් එක සම්පූර්ණයෙන් ඉදි කරාට වඩා වෙනස් හැසිරීමක් තමයි තියෙන්නේ. එතකොට සමහර මෙම්බර්ස් අපිට බිල්ඩින් එක සම්පූර්ණයෙන් ඉදි කරාට වඩා කැපැසිටි එකකින් ඩිසයින් කරන්න වෙනවා. මොකද ඒකේ බිහේවියර් එක හින්දා. උදාහරණයකට බීම් සමහර වෙලාවට අපි දන්නවනේ ඒ කියන්නේ කන්ටිනියස් බීම්ස් නැතුව සමහර වෙලාවට සිම්ප්ලි සපෝටඩ් වෙන්න පුළුවන්. ඒ කන්ස්ට්‍රක්ෂන් ස්ටේජ් එකේ. එතකොට ඒකේ අනිත් පැත්තත් ওই විදිහම ඒ කියන්නේ දැන් උදාහරණයක් විදිහට ගත්තොත් ඇමරිකාව වගේ STM කෝඩ්ස් තියෙනවා බිල්ඩින් එකක් කඩා ඉවත් කරන්න. ඒකට කෝඩ් ඔෆ් ප්‍රැක්ටිස් එකක් තියෙනවා. මොකද මේ කරන්න හදන්නේ අපි පොළොවේ මත රඳවා තිබු ගොඩනැගිල්ල කඩා ඉවත් කරනකොට ක්‍රම දෙකක් තියෙනවා. එකක් තමයි සුපර් ස්ට්‍රක්චර් එකට මොකද්ද වෙන බලපෑම. ඒ වගේම සබ් ස්ට්‍රක්චර් එකට. සුපර් ස්ට්‍රක්චර් කියන්නේ ඔබ තට්ටුවක් ඉවත් කරනකොට ඒ තට්ටුව ඊළඟ තට්ටුව මත ඇති කරන කම්පනය ඊට පස්සේ ඒකට අවශ්‍ය ක්‍රමය ඒ ඔක්කොම ඩිසයිඩ් කරන්න ඕනේ. ඇත්තටම දැන් ඔකට ඇත්තටම කියන්නේ we call it a demolition design stage. You know, we have to do always as we do the construction stage design. And by the way, when we demolishing the building also, we need to take care of it. Also, the other things, other parameter is sometimes assume that the building is on the isolated footings or the raft foundation. So the next land also having the similar kind of building. So if it is blind wall or end to end, so these foundation stresses are being shared by the both land at the end. So if you remove these stresses, what will happen? So that foundations, the pressure bulbs are not coinciding with each other, then it will take to the different level of the differential settlements of the building to the other building also. So sometimes even though you demolish your buildings within the premises, so other buildings also will get the impact because of these differential settlements of the building where the foundation are releasing their stresses through the within the land. So this is a serious case actually, especially when we have incidents that we experience loss in the life also. This is sometimes we think that the non-technical people hired and get it done. But I believe what the effort you put to the design of the building should be given more than that the demolition of the building. in the future where the heavily urbanized area being considered? I hope you got the answer. What?
Yes, yes, Dr. Pradeep. Engineer Mangala, we have many instances that where adjacent buildings were damaged due to excavation for new buildings. What kind of precautionary measures that we can avoid such situation?
Yeah, I think Dr. Pradeep already answered
Yes.
to that
Yes,
question.
certainly.
He explained actually, number one, we have to, especially if you are going for the excavation, we have to select the proper type of shoring. It can be timber, it can be sheet pile, it can be secant pile. So what, I mean, it is very difficult to tell what is the exact method here without seeing the soil condition and the excavation depth, right? Therefore, sometimes the structural engineer, not only the structural engineers, but also we need to get the service of the geotechnical experts. That is how we are doing it. Number one. Number two, sometimes not only the shoring, we have to consider about this dewatering, because we know in Colombo also most of the areas the water table is very high, and when we are doing the foundation or the basement construction, we have to do dewatering. So when we are doing this dewatering, it is very difficult to concentrate on the dewatering process into one land, right? Definitely it will affect to the other lands, and also the due to this dewatering, pore pressure will change. Those changes will adversely affect to this adjacent buildings. Therefore, it is very important to plan the dewatering process. Actually, that is a law. There are some calculations to be done. Therefore, I think it is very important to get the geotechnical experts' advice on this type of situation. Other side, anyway, we have to understand there will be a risk, right? I mean, without taking any risk, taking a risk, we can't do anything. Therefore, I believe it is important if anyone is going to do a building construction adjacent to another building, it is very important to assess the risk and get a proper insurance. Number one. Number two, it is very important to have some sort of a survey. We call it crack survey. I mean, if you are going for a good insurance policy, they are doing it. We have to do the crack survey. And also, we have seen this sometimes there are some cracks appearing due to excessive vibrations, especially when we are installing the pipes. So in that type of scenarios, we can measure the vibrations induced in your buildings or in your area. These things are very common in Sri Lanka. Actually, not even today, about 10 years before also I have used this type of method. So that type of precautionary actions you can take.
How the impact that the amount of water used for this concrete can in damage of the building, or is that also a very common question?
Yes, yes, Manjula, we all know that when we are mixing the concrete, especially if I give answer for the concrete, when I am mixing concrete, this amount of water has a significant impact to the strength. Not only the water, actually, other things also. Therefore, it is very important to measure the ingredients in the proper way. We have seen, I mean, in most of the Sri Lankan small building sites, especially in house constructions, we haven't seen they are using the proper method of measuring, because we all know, and most of the engineers here, the technical people, may have seen something called gauge box, right? We have to use gauge boxes. මම මේක මේ සිංහලනුත් කියන්නම් මේ හරිම කනගාටුයි ලංකාවේ සිමෙන්ති වැලි ගලුයි ඔක්කොම මනින්නේ මේ තාච්චියෙන් එහෙම නැත්නම් සවලෙන්. දැන් සවලෙන් මනිද්දි අපි දන්නවා සවලෙන්වත් තාච්චියෙන්වත් මේ හරියට මේ එහෙම මෙෂර්මන්ට් එකක් ගන්න බෑනේ. එතකොට මේ ගේජ් බොක්ස් එකක් පාවිච්චි කරන එක හරි වැදගත්. ගොඩක් දෙනෙක් මේ ගෙවල් හදන්නේ සිමෙන්ති කොටයක් තාච්චි 5යි කියලා හිතලා එහෙම තමයි ඒක හදන්නේ. එතකොට ඒ ක්‍රමය හරි නැහැ පළවෙනි එක. දෙවෙනි එක මේ වතුර මනින්නත් මේ වතුර මනින්න කියන්නේ ඔබ මේ ගොඩක් සොෆිස්ටිකේටඩ් දෙයක් ඕනේ නැහැ. අතරම සාමාන්‍යයෙන් වෙන්න ඕනේ ඉන්ජිනියර් ඩිසයින් කරලා තියෙන කොන්ක්‍රීට් ග්‍රේඩ් එක එන්න අවශ්‍ය දාන්න ඕනේ බොඩ ප්‍රමාණය කොච්චරද කියලා එයාගෙන් අහලා මේ පොඩි යම් කිසි වාජනයක් කරන් ඒකෙන් මැනලා දාන එක තමයි වැදගත්. එහෙම නැතුව මේ අපි ගොඩක් කලාට මේ දකිනවා මේ ලොකු බිල්ඩින්ග්ස් වල මේ පුංචි ගෙවල් එහෙම හදද්දී සමහර මේ කොන්ක්‍රීට් කරන පුද්ගලයෝ සාමාන්‍ය පියවි සිහිනුත් නෙමෙයි ඉන්නේ. ඉතින් එතකොට ඒගොල්ලෝ ලේසි වෙන්න වතුර එහෙම දානවා අනන්න. එතකොට මේක මං හිතන්නේ විශේෂ ප්‍රශ්නයක්. මොකද අපි ඕනම ඩිසයිනර් කෙනෙක් කොන්ක්‍රීට් එකක ස්ට්‍රෙන්ත් එක assume කරන ප්‍රමාණයක් තියෙනවා. ඩිසයින් කරන්නේ ඒකට. ඉතින් ඒ ස්ට්‍රෙන්ත් එක එන්නේ නැත්නම් ඒ බිල්ඩින් එකට එන ලෝඩ් එක දරා ගන්න බෑ. So it is very important to ensure that the strength of the concrete should gain with the designer wants, right? There, I mean, if you have add more water or something, if you can't get the mix in proper way, you are in trouble. So it is very important.
Thank you. Then I would like to again go to Professor Ranjith Dissanayake. Sir, structural health monitoring, as you said, is a measure of the level of risk that is acceptable to stakeholders. Safety should be there. In the meantime, economic safety also should be there. What can you say about it? Dr. Pradeep, can you hear me?
Yes, I can hear you.
Right. Sorry, Manjula, the question is to me, right?
Yeah, that structural health monitoring is actually a measure of risk that is acceptable to stakeholders. Safety also should be there, and the meantime, economic safety also should be there. What can be done? What options are available, and the associated trade-off in terms of cost benefits?
Yeah, cost benefits mean the once if you do not care about the structural health monitoring, eventually structure will collapse. Then you will lose the value of the whole structure, like the failure of some of the building. Therefore, you have to invest for the structural health monitoring. And then because if you, for example, if you are changing the structure, if you feel like, okay, I'm going to increase something, I want to change it, something like that. But sometimes still the building may collapse. Therefore, you have to understand what happened to the building when you increase the floors or when you increase the loading. So exactly understanding, you have to provide the reinforcement and the jacketing to the structure. Therefore, this is really, if you analyze, it is an economic benefit is there. Because you increase the life, you increase the durability of the structure, and you enhance the life of the structure. So that is there's a really cost benefit by doing the structural health monitoring.
And Professor, you are very good at actually forensic engineering. Sometimes throwing away valuable information, approaches to speech extraction as sometimes volatile environment. How to basically identify the dominant component of a particular scenario?
I mean, structural health monitoring.
Yes.
Yeah. This is actually so. How can I answer this question? I think now, when you get the big sense, because we are in the business, sometime nowadays, especially because of this Bangladesh collapse, if you are to give the order, before giving the order, the people who are giving the orders to you ask for the structural health monitoring report. Why? Think, if you want to have the, say, particular brand gap shirt of 1 million to sell in the summer, if you give to the contractor, like what happened in Bangladesh, if the factory collapse, you will not be able to get that product on time. If you could not get the product on time, you may not be able to sell it. Therefore, nowadays, before you give the order, they will ask for the structural health monitoring report. Therefore, we have been continuously contacting to get the structural health monitoring report before finalizing the order. Hope I understand.
Yes, thank you. We have a few more questions. Only would like to go to Engineer Mangala. All designers said uncertainty is a risk. What is actually the unit of risk, and is it only money function?
It's like this. When you ask the risk, we have to be very careful about the symptoms, right? I mean, before collapse, any building, they will give, most of the time, they will give the enough notices, right? For example, I'll answer this way. If there are some significant cracks on your structural elements, when I say, I mean, if someone is interested about a house, if there are some cracks on your slab, beam or columns, if you can observe, especially not the hair cracks, but the crack we can put a tip of a safety pin type of thing, please consult immediately the structural engineer. Number one. Number two, if there can be so many cracks in the brick walls as well, where, I mean, there can be so many reasons, but if that is a structural crack, definitely it should develop with the time. Therefore, we advise, if you can see cracks in your walls, please observe, please monitor, check whether those crack widths are increasing with the time or not, right? Probably in Sri Lanka, most common and the very basic method is there just to glue the piece of newspaper part on top of this crack. If you can see this, I mean, if there's a damage to this piece of paper, that means it gives a notice saying that crack is propagating. So at this time, if you observe that type of thing, immediately consult the structural engineer. If there is no development, there can be so many reasons, the thermal cracks and other things, you may not have to worry. But if you can see these developing cracks, answer is yes, you have to immediately consult a structural engineer.
Thank you, Engineer Mangala. I have another two questions. Dr. Pradeep, we need engineering knowledge to get actually measurements, monitoring, research, feature extraction. As most of the time it is trial and error for this structural monitoring. So there is a risk of trial and error, simply actually black box. So if I say there's a loss function also in a decision, am I right?
Thank you, Manjula, finally asking very broad question. I'm sure Professor Ranjith also will add some things. So we always in engineering or whatever the field we consider, we keep research ongoing. For example, as engineers, we know that still for the soil, we today take a safety factor of 3. Even whatever the research we do all around the world. So this is the way we keep the safety factors. So what we do is a design. In a brief definition is the where we tolerance in between the cost and the safety. So if you take a same type of structure, what we do is sometimes in a different purpose, in a different kind of thing. So code recommend a different kind of safety factors. So that's why especially if you see the ACI code, the brief definition for the design is to make a decision in between the cost and the safety. So wherever we do the research to be applied to the normal industry, but still it has the challenges because we do a lot of research in the laboratory. Then it has to be transferred to the industry where the environment is going to be so changing. For example, so in addition, you were asking about like trial and error methods. Now today, there is one call, the research line is simulations. We can do probably today how the aeroplanes above the 33,000 feet above, how the stresses develop within the body. Now that kind of the research has gone to the simulation at that level. But at the same times, what we need to do is a trial and error to make sure that this is to be validated our designs and the simulation with the experiment. So always as academics, especially what we do is whatever the simulations we do, for example, finite element or any kind of simulation, we validate through the experimental proceeding. So that can be part of the trial and error where we wanted to see. If you remember the example which Professor Ranjith Dissanayake was explaining the Kalani Bridge. So the actual values, design value and the finite elements value are always been matching. Unless you will not be able to give exact conclusions to the issue or else the client requirement. So always I think the loss part is there, I believe it, but we work for the better. So that's why even the world, especially in the engineering, the highest budgets is going R&D. So wherever the institution you get, so the R&D part is very high. Especially the innovation, especially the industry looking for the now innovation should be working on the R&D. In other hand, so the few years back, let me talk about the material. For example, we not bother about much the durability, especially. So point to point, we haven't considered, okay, so the environmental challenges we have not. But if you take, some kind of today situation is we do selections of the cement, for example, based on location to location, based on the case to case. But earlier, probably if you, me, and were the undergraduate, we have a single type of cement that we use for any kind of mixed design. But today we do have plenty because we wanted to optimize the structure. So I would say if you take 2 decades back, what the loss you have has been optimized by now. But it is a long way to go in the future because now today world is talking about sustainability, reuse of the material, and the green brown, not the brown. Always so that the sustainable aspects become more. And in terms of the carbon dioxide emissions, so everyone is looking for any kind of products in the future probably come with what is the usage of the carbon dioxide, where we have not think 30-40 years back. Probably you need to understand. And it is not the matter of we put the structural optimization also the part of our structural engineers design. So we usually do for the more safer, we do more things. But we absolutely see what the clients want, and we absolutely manage and optimize through the design process to use the minimum material to take off the carbon dioxide consumption as much as possible. That is what the millennium goal where we want. So trial and error and the R&D, the research is a prioritized in the world right now to make sure that the planet is more livable for the next generation. I'm sure Professor Ranjith also can add something.
Let me have a word quickly, Dr. Pradeep. Thank you very much. I fully agree to that aspect. There are many opportunities and many possibilities available in regard to sustainable construction, sustainable materials, which are at least as durable or even more durable to currently good use products, right? And we must understand that. And I think especially in Sri Lanka, we have a big opportunity to adopt change for the betterment, not for worse. But what comes first is that we need to be willing to accept change, and that things have changed in the world due to research, due to many projects which have been executed around the world, and with that also good results. So I think I'm sure Professor Ranjith from a Green Building Council can confirm that and support that. But let us go on the one hand side green, on the other hand build more durable in the end for the betterment of the client as well as of the planet.
Okay, I think we are getting to another topic of sustainability and sustainable material. It might end up with 1 hour, but anyway, I make it short that the material is becoming the biggest problem, because the thing is that we are getting more and more increase the population, but the problem is that we are has the minimum number of resources. Resources never be expand. Therefore, in this world, we have to make sure that the sustainable use of the material, because we have been using the linear economic model in construction. We cannot do anymore. We have to go for the circular economy, where all the material, all the demolition taking place must take back to the material cycle. And the extend the life is another way of doing of the, it is in the structures, and the doing the retrofitting structural health monitoring, keep the life of the structure. That means otherwise we may have to demolish it and go for the new construction. New construction is always the material. So therefore structural health monitoring is the way to for the sustainability, while finding the alternative material, optimum design, recycling, reuse, the structural health monitoring topic that we have been talking today is the, in a way, reduce the material, energy, resources in the economic. I can't remember, I might have explained this before sometime. There has been the case that we are given the structures for the demolition, but we said that don't demolish it. Why not we repair it? Even the right now also we do the construction in Kandy. Originally the building was to demolish and build something. I said that no, we will change the design little bit and we use the existing building as it is and do some modification. We did it. So that is a saving of the material, saving of the labor, saving of the energy. That is a sustainable. We as engineers must make sure that our decision, we are asked to the client, they are laymen, they don't know the sustainability. We should ask them about the rethink about the whole process that we are doing in construction. I hope I answer enough.
Yes, thank you, Professor. And actually, now almost 7, and we discussed for about 2 hours. And I think we covered many areas today on structural health monitoring in terms of preventing building failures, and hope our participants were reasonably. And seems it was very informative and productive sessions today. And I think we have to thank Professor Ranjith Dissanayake, Engineer Mangala Silla, and Dr. Laksit Pradeep for sharing very valuable information and for your time for the benefit of our engineers and the public at large. Future also, we hope to conduct this kind of awareness session. You can join with ISL. And I also say, Professor, we have Engineers Without Borders in Sri Lanka, and that also they are, and you are the president of this movement in Sri Lanka.
Yes.
Also, resource person. I think like to get few ideas on that. We can actually invite companies, organizations to join with Engineers Without Border movement and join hand to aware our engineers and general public in future.
Yeah, that is the international organization we call Engineers Without Borders that present most of the countries. I'm the president for the Engineers Without Borders Sri Lanka. So we have been doing various projects, but recently we have thought we must do more work than previously. Basically, we are trying to take the sustainable engineering concept to the rural. So it is good that too, even my ministry where I'm in the State Ministry of Rural Roads and other infrastructure. Actually, recently also we started constructing the smaller bridges. We wanted to build like 5,000 bridges from next 5 years. When we inquire the places, we end up with the 12,000 bridges. So we are trying to use not only a traditional method, even we are trying to use the used material available in the country, like the telephone post, railway sweepers, and various other items will be used to construct these 12,000 bridges in need for the community. But that is where we go for the, we have to, as engineers, we have to go without borders. We have to go across the border and understand the community and provide them the sustainable solution. Okay, Manjula, through the Engineers Without Borders, we'll try to do something next year.
With that remark, thank you very much again, all 3 panelists, and would like to give back to the control, Nishan.
Manjula, thank you very much. Thank you very much for the successful moderation and your kind thoughts and inputs. Dr. Pradeep and Engineer Mangala, similarly, thank you very much for your kind participation, as always. Professor Ranjith Dissanayake, thank you again for the great thoughts and inputs throughout the session and also especially in the panel discussion. So ladies and gentlemen, 20th knowledge sharing session by INSEE I2I collaboration space and ISL collaboratively presented you today. And this was the fifth knowledge sharing webinar session. Today's session was conducted by, as you know, Professor Ranjith Dissanayake on structural health monitoring prevents building failures, followed by the panel discussion just finished. So let me invite Dr. Mosa Balbaki, Head of Products and Solutions Portfolio, one of the well-known and well-reputed, again, a resource person in the global context. He is heading the Products and Solutions Portfolio of INSEE Cement. Dr. Mosa Balbaki, over to you to give the vote of thanks.
Thank you. Thank you, Dishan. First of all, I would like to say that I think as most of the participants, we really feel today privileged to have this type of expert panel discussing on very complex topic. Let's put it like that, okay? Because we know very well that concrete is a very noble material. In Sri Lanka, if I take consumption 300 kg per capita, we are pouring every day to develop our country about 15 million cubic meter of concrete. Therefore, I join Professor Ranjit, I join Dr. Pradeep and Engineer Mangala that we have to, as engineer, design concrete according to the expected service life. Therefore, the topic is complex, and very often, if I look, its structure is composite very often. Therefore, we have to look to the composite material, and it was very well covered because we saw a lot of examples where we see clearly that the system can be very complex. But what I want to say that when I look today Europe, I look North America. Very often structure health monitoring is done only to extend a certain service life, because when we arrive to a point where structures start to get to the, let's say, to the end of life, this is a very important element. For example, it was not done in Italy. Professor Ranjit showed the case of the bridge in Genoa, the Morandi Bridge that collapsed with almost 40 people died. Just because there is a high social cost behind that. Therefore, that is why this operation is very important, because we are touching not only environmental, we touch safety, and also we are touching the element of to develop a country. It's very important to develop a country today is we have to head with sustainability. We cannot anymore afford to do what we have done the last, let's say, 20, 25 years. Okay, we need to take into account that today there is innovation, there is new technology that are in place. When I look, for example, Port City, all the strategic projects today are really using technology where the compressive strength is not the unique engineering property that is specified. You agree with me? Because when I look most of bridges, when they collapse, not because the concrete has not achieved its strength, it's just that the system has collapsed because, for example, reinforcement has corroded, for example. Okay. Therefore, thank you so much. Really, it was a very somehow interesting topic today. Very complex, I should say. We have reached 260 participants. That was great to see really that how much people were really interested about the topic. And I would like again, thanks really the panel, thanks Professor Ranjit, thanks Dr. Pradeep, thanks Engineer Mangala, Engineer Manjula, all of you, for your very generous, let's put it like that, contribution with a lot of experience, a lot of somehow also take home for us to really start to build for life, build more sustainable our beautiful island. Thank you so much.
Thank you.
Thank you
Dr.
very much, everyone.
Thank you very much.
And have a good weekend.
Thank you, everybody.
You too. Bye-bye. Bye-bye.
Thanks a lot.
Thank you.
See you again at the 21st knowledge sharing session. Thanks all.
Absolutely.
Thank you.
Thank you very much, everyone.
Thank you. Thank you.
Thank you.
Bye-bye.
Bye-bye. Bye-bye.
Thank you, Dishan. Thank you, Nanana and
Thank
team.
you, Dishan. Thank you.
Thank you.
Thank you, everybody.
Ranjit.
Bye-bye.
Thank you very much, Mangala. And let's catch up soon as we're available to do so.
Isuru, thank you.
Thank you.